Hi, and welcome to a video about solving compound inequalities. And the first thing I want to point out is this is called a compound inequality because it has two parts. Compound inequalities look like two problems together connected with the word and or the word or. In this problem, we're going to do an inequality that's connected with the word and. These kinds of inequalities are called intersection inequalities. You solve this the same way you would solve any inequality or equation. So go ahead and proceed as you think you would. It's just that you have kind of two separate problems that you're going to put together at the end. So the first thing I'm going to do is make sure I'm using my properties of inequality correctly. Subtract 1 from both sides. 2x is greater than or equal to 2. Divide by 2. X is greater than or equal to 1. I also have to solve this other problem. We're going to do exactly the same thing using our properties of inequality. So we're going to add 4 to both sides. 3x is less than or equal to 21. We're going to divide by 3. X is less than or equal to 7. And then we need to put these two parts together, and we're going to connect them with the word and. The way we're going to do this now is we're going to put these on a number line. So when you make your number line, anytime you're graphing inequalities, you're graphing a picture of all of the possible solutions. So just to put my numbers on here, we're going to put our x values that go with this part. So x is greater than or equal to 1 would be here. We need to fill in the dot. This is going to be a closed dot because this is inclusive. That means 1 is a solution. And we want any values of x that are greater. So this is going to go on forever. However, we also want solutions to this piece. This is x is less than or equal to 7, so we need to fill in the dot indicating that we include 7, and x is less than or equal to those. So this word and is significant because now we want the points that satisfy this inequality and this one simultaneously. Those points exist in this overlapping region. So our final answer is this interval, and we can use interval notation to write this answer. So we could say our solution set goes from -1 to 7, and those are closed intervals. Or we could also write this using inequality notation, and that would be the x exists in between these 2 points. -1 is to the left, sorry, that's a +1, and 7 is to the right. You need to make sure these are in order so that when you read the sentence it makes sense. So -1 is less than or equal to x, which is less than or equal to 7. So this is a solution. It could also be written this way using our interval notation, and this is a picture of the solution set. So I hope this gives you a little better idea of how to solve a compound inequality. This particular one is an and inequality, also known as an intersection inequality.